Okay, good morning everyone. Good morning. Second session for the second day of the 67th edition of the IT Quest Tour. Some of you remember we met Leil or Leil Storage, depending if you want to extend the name or not. We met Alex and Piotr at this time. It was in April 2024 in Rome. Okay, and since that, they continue to develop a lot of things. Today, Alex will unveil new key development, I think a very important new milestone for the company. So I'm glad we will hear this live, because this is a new announcement with us.
Met a couple of times. It's a big pleasure to meet you all, and with some of you we've met before, a couple of years ago. And today I'm going to talk about recent developments with us, and as well I'm going to tell you about the rebranding that has just happened with us. The reasons for that, the genesis of the company, what we have on our roadmap. And unfortunately, our site was supposed to be 2 people today, but my co-founder and CTO got badly sick just 2 days ago and he couldn't attend. So this deck is split into business part and technical part. I will cover them in the sequential manner, just like we work with the SMR drives, all sequential. So we are starting with the business part, and I would like to encourage you to have this session as interactive as possible. So feel free to stop me anytime, ask questions, and I will elaborate on that. So starting with our new old name, we decided to drop the part of storage. So now we want to be known as Leil, for simplicity's sake mostly. And the etymology of the word Leil has deep roots into Estonian language, because we're the company based in Estonia. And Leil means the special type of steam. Not your ordinary steam, but just the steam which is generated when you pour the water in sauna on hot rocks. So this is the special type of steam. And we believe it symbolizes the nature of rebirth in storage that we try to spread across the world. What our new unified brand and unified vision brings. So we have created this pyramid that we want to stick with for years to come. And on the top of this pyramid, our open core, open source GPL3 file system, which you may have heard of as sauna, which is going to be named Leil FS now. And by unifying the names, we want to get rid of this misunderstanding that in some companies working in our field can happen very frequently. One of the good examples, good/bad examples, our good friends from BGFS. Because they always have to deal with this, how a thing you par is related to BGFS. And we wanted to remove this inconvenience, and in order to do so, we united the names. So Leil FS is the community, open source, fully POSIX compliant file system, which is free to use, available on GitHub. And the next layer, our proprietary offering, which is called Leil OS, that supports SMR drives, that supports exabyte scale, that supports sustainability features, that supports energy efficiency features, and many other features which are on our roadmap. And in the foundation of all of that, our proprietary component that we call the smart engine. In the lower layer, you can see this abbreviation, which has something to do with the smart drives, of course. It's the logic of the sequential web with the drives which is applicable not only to SMR drives, which is our favorite drives, but to CMR drives as well. Because we can work with any drive, meaning that we can work with CMRs, we can work with SMRs, we can work with mix of those, so we can work with the drives of variable capacities and all of that, which is not always the case with any other file systems. Here are the agenda for the business slides that we are going to cover, which goes in line with what Philip sent us, and these are the items that I'm going to cover. So the company was founded in 2022. Technically, it's reasonable to say that it was 2023 because it was just the company formation that happened in the very late of 2022. So we started working in early 2023, and we spent approximately 2 years to build our product first. And from the get-go, our idea was to build our product based on the technology until now unavailable to on-premise users. I am talking about the SMR drives. I think many of you or all of you have heard about them, but this paradox about the SMR drives has become even more visible since the last time we spoke to you in Rome 2 years ago. We had these interesting situations going on the market, and I will cover some of you for better understanding and more complete picture. So SMR drives per se is how we see them and how HDD makers see them as well, can be named as the biggest hidden elephant in the room. Because today, more than 50% of the shipped capacity worldwide ships in the form of SMR drives. But almost no one heard of them. How come? Obvious question. The answer is that most consumers of these drives are hyperscale people like Facebook, Amazon, Microsoft, and some others that have adopted the software stack to work with the smart drives because even though they look like your ordinary hard drive, they require a special approach to work with them because they accept only sequential kind of workloads. And we decided to unlock these efficiencies, these economics to the broader market, to the enterprise market, because we have had some exposure.
Yes.
Oh, okay.
Because we have had some exposure to these drives in our past experiences. So we started building our distributed file system that supports these drives, and as of now, it creates for us a very distinct advantage versus the competition because SMR drives, in fact, are supported by a few file systems already. But the problem with those file systems is that they are either single drive file system, I'm talking about BTRFS file system, for example, or they support them only at the scale of one server. So the big data cannot be kept on them. Like XFS, for example, recently supported them, but the scale is limited to one server. So this was our mission to unlock SMR drives to the broader market, and it took us self-financing, building the team, and approximately 2 years of work. And the product was mature, ready, robust, and ready to ship approximately a year ago. So since then, in the autumn of the 2025, we raised our seed round to spearhead our development activities, and we are working on that since then. Now, a few words about our mission and hard values that we are trying to unlock for the broader market. We want to keep it as simple as possible, so most times we're talking about 4 pillars or 4 hard values that we unlock with our storage to the broader market. First advantage extra capacity comes from SMR drives themselves. Because SMR drives give a user 20 to 25% more capacity versus the standard drive at the same cost as the next drive in capacity lower. A real life example, 26 TB CMR drive costs the same as a 32 TB SMR drive. You get 6 terabytes for free, and this gap is supposed to get even bigger with the HAMR adoption taking off, and after HAMR what we can expect, what is called HDMR, is also on the horizon. Second pillar.
Where is the extra capacity coming from? Why was it on the drive?
Where does extra capacity come from?
Yeah. But why does the vendor reserve so much space?
It comes from the acronym SMR, which stands for shingles magnetic recording, like shingles on the roof. It means that the tracks on the drive are overlapped.
Yeah.
And it creates extra density, which is realized in those extra terabytes that we were talking about just now.
So you're removing in fact some space between tracks and then use it.
Between adjacent tracks is overlapped.
Yeah, okay.
So this deficiency is coming from this fact. But I mean, it sounds so like good and sweet, but it comes with a caveat. As I mentioned a few slides ago, that SMRs obviously provide you this extra capacity, but in return, you can only access them in the sequential way. And you have to deal with these zones in a very sophisticated and intelligent way to make it work. So it's not just like I bought the drive, I put it into the server, and it's pinned. Fortunately not. So to the next pillar, pillar number 2, extra performance. And we had a very interesting evolution and journey with our product, because I think it was even the case when we met 2 years ago in Rome. We were branding ourselves as Leil Storage. Storage designed for backup and archives. The more we developed our product, the faster it grew and it got. And now we have the situation when, for example, testing big enclosures with 100 drives, we are hitting the limits of PCI Express bus rather than disks. And now we are able to squeeze from 95 to 99% of the theoretical maximum physical performance from the enclosure. So we are no longer slow, we are no longer cold, we are no longer backup and archive. We are nearline HDD-based storage, which is well suitable for every workloads or any workloads that can run on HDDs today. When we are not talking about random things like which is served by flash drives, we are in no way competing with the likes of DDR plus data wake, because they are flash-based, they're super fast. We are not there. But the economics in the world and data distribution is set in a way these days that approximately 15% of the data is kept on flash and 85% is kept on HDDs. And we want this data which is kept on HDDs to provide the maximum possible performance possible. So next pillar is extra longevity. Where it comes from? It comes from 2 distinct features that are available in standards that we are working on. They are not fully supported yet in the code, but they are scoped and engineers are implementing them as we speak. First technology that provides for extra longevity is the one which is called autonomous drive regeneration, or ADR. This technology is known under the second name, which is head depopulation. What it means? Because it's a very interesting one, and we were surprised finding out that no one has tried to implement it before. just imagine every drive, every hard drive, has from 10 to 12 platters in it. And each platter has two heads reading from one side and from the other side. And based on the statistics that we received from hard drive makers, because we worked with all three of them very closely, approximately 50% of all failures happening in the entire world with hard drives, 50%, have something to do with failing of just one head. And in the drive, you have at least 20 heads. Western Digital Seagate has drives with 10 platters. Western Digital has drives with 11 platters, meaning 22 heads. And Toshiba recently announced that they're going to make drives with 12 platters, meaning 24 heads. And these drives are perfectly fine to run longer without bothering with replacing them, scrapping them, doing all of that for the sake of circular economy. And we are able to unpark just one head, meaning that the drive will lose 5% of its capacity, but it will remain perfectly healthy to work further. So the idea is to shrink the failed capacity and leave drive as is in the server enclosure without recycling it, because it can work.
So can we say that one head is unvalidated? So the platter can be accessed, but all the other remaining are accessible?
Exactly.
But what about the data on this platter?
This data on the failed platter is being evacuated in the background.
Yeah, to other...
Yeah, and actually the benefit, I'm getting into the technical deck a little bit, but the data is being evacuated and it saves you the time for the disk rebuild, which would happen in case of RAID storage, for example, because rebuild will not be necessary in this case.
How do you evacuate data if the head is dead?
You have a copy of the.
We have Erasure coding.
Okay.
And,
with external, with external things.
Toshiba or Western
With external.
Everyone has it. Everyone has it.
It's inside the drive, so it's not your technology.
It's the mechanical technology which is present, but through software we unlock this technology so that it can be used.
Okay.
I mean, the hardware world has invented so many things already which are not realized in software stacks, unfortunately. And we are doing this.
So instead of marking the entire drive as failed or inaccessible for any reason, just because you lose one head, you continue to use 19 heads among the 20.
We can use 95% of the original drive capacity, in other words.
Okay.
Yes.
Yes, but I mean,
Okay.
then the platter with the one destroyed head, you still read parts of it.
No, it's marked as disqualified in a
Yes,
sense.
but then you should use at least 90% if there are 10 platters.
How it works? As an example, one disk,
Yeah.
10 platters,
Yes,
2 heads per one platter,
yes,
up and down, right?
yes. So it's one side, it's a...
One side or one platter,
Okay.
yes. And the second technology that contributes to extra longevity is called CDL, which means command duration limits. And this technology is available in Linux, and until now it's not been supported by software stacks as well. Why it's important, especially in the world of AI, where we are living with all of us. What it means, how it typically works when the software tries to read the data from the drive, especially when we are talking about parallel file systems that are doing the reads in multi-streams. Like in the sport team, just imagine, you have the running competition, 10 people in each team, 10 sportsmen. How the result of a specific team will be defined at the end of the race. it will be defined by the time that it took for the last sportsman in the team to get to the finish line. So same thing kind of here. When the data is trying to be read through multiple streams, and for example, one stream hits a bad block on the drive, it will try again, try again, try again, try again. And this read operation will not be complete until it will be cancelled. But the default timeouts for canceling this command is very long. And it means that, for example, with AI training, the entire exercise can extend for much more time than it's needed. And by implementing this technology, we are able to disqualify the read attempt that cannot be completed in the reasonable time much faster. And by this, we will improve the overall performance of the software stack.
So you will then execute this command once more, or we will not execute it at all?
We will stop it.
And then, I mean, this command is there
And
for
then
a purpose.
it will try to read from other block of the drive, which responds fast. And because we have copies of all the data, because we are using erasure coding. So these chunks of data can be read from some other place that provides these responses faster.
Ah,
Next, fourth pillar here is called sustainability, and here we're talking about feature set, distinct feature set that allows us to save energy by using big data clusters. And again, we are not reinventing the wheel with this technology. We are not rediscovering America. We just use the functionality which has been present on any hard drive for decades. I'm talking about the so-called pin 3 feature. It's the special power pin on the back of every hard drive. What we do? We are capable of intelligently manage the power states of the drives through our software layer. And when we're talking about managing power states, it's kind of important to understand that we are not talking about like on-off. There are more of them. There are 6 power states of a drive, and each state is explained by the special wattage, how much power it consumes in each state. And we are able to enter the drive in any of these states as necessary and wake them up back again when it's needed. And if we enter the drives into the hibernate or sleep states, it means that the drive will consume almost no energy, but it can be woken up again when the data access is needed. So in our storage systems, we are able to significantly save the energy bills. Of course, some may say that when people deploy hundreds of clusters of GPUs, does it make any difference? For GPUs, it doesn't make any difference. But people are thinking about our part of responsibility or part of duty in this storage industry. So we are taking care about the storage component, and with the storage component, we do what it is possible to optimize the energy consumption.
I mean, there have been other storage products years before which tried to use that feature,
Yeah,
but they weren't very successful. Disappeared from the market quite quickly.
yeah, I know the answer why. And this feature slash functionality that you're talking about is known in the storage history as MAID, which stands for massive array of idle drives, like MAID. The problem with this technology was that it was reliant on rate controllers. So the logic was locked into the, let's call it PCI Express card that tried to manage this energy consumption landscape, having very little brain in it. And now this management layer is taken from the hardware, tiny controller, onto the host operating system, which has significantly more capacity to manage it, and it's much more sophisticated. One of the companies, I think, well-known companies that try to implement this is Nexan from the UK. We made. So next we are moving to the storage landscape and the situation with SMRs that I partially have already covered, but a few more words here. Why we believe that we can be very actual in the today's competitive market, and why we believe that HDDs are here to stay for many years to come. It comes from the fact that, as I mentioned again, 95% plus of the world's data is kept on hard drives. And 2 years ago, 3 years ago, there was a big push from the likes of Pure Storage, Everpure now, saying that HDDs will be no more in 3, 4, 5 years. And it was in times when the pricing gap between HDDs and flash was like 5-to-1, 6-to-1, 6-to-1 in favor of HDDs. Now it's 10 plus to 1. And this keeps growing. So the incentives for people to start moving from HDDs to flash is even less these days. And at the same time, it is important to say, like, some people are still thinking in the old paradigm of thinking when it comes to HDDs. Like, HDDs have very little IOPS. What can I do with it? Or what can you do with it? We cannot do with it anything, because we have this situation when the capacities of the hard drives are growing every now and then. A few years ago, the default drive was like 18 TB, now it's 30 or 32, next it will be 40, but IOPS are stuck from the capacities of 10 to 12 TB. IOPS are not growing, and when we're talking about using HDDs with the data that can be kept on them, we are not talking about running virtual machines on HDDs, because no one in their sane mind would try to do it these days. We are not talking about running databases on HDDs, just not needed. Workloads that can live in the excellent way on flash must be run on flash. But what is capable of running on HDDs can be running on HDDs, and SMR drives, in this case, provide very compelling advantages. So, to the hard values that we are unlocking with our software layer. As I mentioned in the 4 pillars or 4 hard values in our storage, we have tried from the very inception to support the biggest drives on the planet, which is SMR drives. As again, when we are talking about this biggest hidden elephant in the room, it's very interesting situation when you go to the website of Seagate and you look at the latest drives. All of them in the fine print, like font number 8, font number 6, will mention that those are SMR drives. Western Digital doesn't hide it so well as Seagate does, but all the biggest drives are SMR drives. And even if you go to the outsider, all 3 of them, to Toshiba website, you will see that the biggest drives are SMR drives. It's happening, it's here, and it looks like there is no other way. I will not name explicitly one HDD vendor. It can be guessed rather easily, but there are, let's call them city gossips, that in a few years from now, the only drives being made will be SMR drives. Why is that? 1 or 2 years ago, Seagate and Western Digital stopped publishing the number of units sold per quarter. They only publish the ship capacity in their stock exchange reports every quarter. Just the ship capacity. Why is that? Any ideas?
Because our drives are only for backup, and SMR are quite convenient for backup.
They are living their golden age now because they sell more and more every quarter. But the reason is that in order to satisfy this ever-growing demand for shipped capacity, the only way to quench this thirst or satisfy this demand is to ship the biggest drives possible. Because in this case, you will need to ship less of them. And you will not have to build new factories to build new hard drives because it's damn expensive. And the only way to ship more capacity with the biggest drives is again our favorite acronym SMR. There is just no other way. Because the gap between SMRs and the next CMR in line is big. And the cost to make is basically the same. So vendors are facing this question for themselves. Should I invest, I don't know, $300 to make 26 TB drive? Or should I invest same $300 to make 32 TB drive and sell it for more, for example, or the same? So they are doing this, and as I said, the city gossips tell us that possibly the ratio between CMR drives being made and SMR drives being made in a few years will shift significantly in favor of SMR drives. We will see. So what we are doing more in terms of the hard values. When we met 2 years ago, I think we were in the situation when some prospects from us demanded to support S3. We were like reluctant to do it, but then we surrendered and we supported S3 through Min.io. We integrated Min.io into our storage like in the past many vendors did. But then we decided to drop it because Min.io was tremendously difficult to maintain, and the code quality was also not like up to the standards. And some time ago, we decided to integrate very deeply, very natively, a very good product from the company called Versity. I think you know them. They developed open source S3 gateway. We did this, and we are creating the file abstraction system layer to integrate it even more deeply into our software, and we now support S3 in addition to our core functionality, which is POSIX distributed file system, NFS, Samba, HIPS. It's all supported now. Speaking of the economy, and more so economy of scale, when we are talking about distributed file systems, and we are talking about SMRs in the context of distributed file systems, we're not talking about installations like 60 TB, 100 TB, 150 TB. We're talking about something more. Just yesterday or the day before yesterday, I received the request. Can you give us the ballpark, what would be the price for your storage for 60 TB capacity? I said, I apologize, but we are out of the league here because 60 TB means just 2 drives. Can't actually realize the letter D in the word distributed, right? So we're talking about big capacities, and when it comes to big capacities for people operating multi-petabytes or hundreds of petabytes of data, being able to save up to 25% just on SMR drives is a big deal, because it immediately means that they can save tens of millions, even hundreds of millions, depending on scale. About economy, still in the storage world, there is the prevalent way of thinking that tapes is the cheapest storage medium. They are, when the comparison is done, in the favorite way by many people, we call it internally, excuse my language, like apple versus horses.
Apple versus horses.
Horse like animal, horse.
Yeah.
Yeah, as in order to compare storage price with option 1 and option 2, you need to compare based on the common ground that you need to come to in the first place.
We have the saying apples compared to peaches. So
Apples, if it were apples to peaches or apple to pears, it would be more or less fair.
yeah.
But the way of typical comparison is so far from being fair that some education or enlightenment is needed in the first place.
But I think the main advantage of tape is that the tape is out and that you can have an IO gap
Yeah,
between the tape and
Yeah.
the other work. And that is something you're not going to use, I would guess.
Okay.
exactly. Air-gapped environment is not what we are targeting. In theory, it can be implemented, but we are not really designed for this, and I agree with you on that. At the same time, when it comes to tapes, the biggest misconception is that people are trying to compare the cost of the cassette, assuming or implying that this is the actual cost of the tape installation. They are completely forgetting about racks that they need to deploy, libraries, readers, and all of that.
Maintenance. Maintenance,
Yeah.
Maintenance, of course.
very costly.
And also a typical comparison that we see in the field, like they compare one copy, so just raw capacity of tape, with something in the storage. But your normal storage comes with, for example, erasure coding that provides for data redundancy. And data is stored safely. Because with the tapes, to get into the comparable level, you need to have at least 2 copies. And it automatically doubles your cost. So without further ado, we had these real-life exercises with big tape consumers. For example, one of them was running 360 petabytes worth of tapes. And we can be cheaper as the complete solution, meaning hardware plus software. And of course, we will be times as fast, and the data will be, we like this word, the data will be actionable, because with tapes, they have own advantages, and as you rightly said, we cannot beat air-gapped scenarios. We cannot. But we can provide data access almost immediately, which tapes cannot do.
Yeah, and tapes need to be refreshed.
It's the other challenge of the current times with tapes, because some people, and we know these people, they want and try to use tapes in the partially AI use cases. It means that the data needs to be reread more frequently than the tapes are designed for. Because I don't remember the exact number, I think the tape can be rewritten 250 or 300 times only.
Yeah,
And when it is used more frequently, based on the demands, for example, of AI training or whatever, it will live its final day much faster than it was promised during the day.
but
when
this
the
point
user
was about the library. If you change the library, the reader, you need to move the tape to a new standard LTO 6 to LTO 9 and so on, because you have retrocompatibility but limited.
They have issues with that,
Yeah.
with the backward compatibility with the latest generation. But again, no single bad word about tape. It has own fan base, which is very strong. Tapes, we have the chief revenue officer, the German guy, and he likes saying that when I started in the storage industry 30 years ago, the first words I heard when I started was that tapes will be no more next year.
Yeah.
So they're still there, and they will be still there tomorrow and the day after tomorrow, and in the next decade for sure. But what I'm saying here is that we can beat tapes on the home turf, on the home ground, with price, which is surprising for many. And to make things even easier, you can see it on the slide in the lower block about 10-minute deployment. A few months ago, we embarked on the very interesting journey trying to make our open core, open source file system more popular. And recently, we have been accepted into the next Ubuntu long-term release, which is 26.04, that will be released end of April. We will be there as the official package. Same happens with Debian, and next in line would be Fedora and Proto Linux.
What was the third one? Third one?
From Linux,
Yes?
Fedora.
You do know.
Now, a few words about use cases that we are a good fit for. So, typically, we have here the workloads that benefit from the sequential character. We have the workloads that benefit from large-scale data. And we have here workloads that can definitely benefit from extra capacity and extra performance coming from our software stack. CCTV storage is the ideal case. AI and HPC work here. Active Archive. We have the operator for Kubernetes. We have the Docker image. We have a few very good customers in media. And backup is the obvious choice coming from the old days when we branded ourselves as the cold storage. What I wanted to cover separately on this slide, it's not mentioned here, but it's like a new thing happening with us that we don't pay much attention to. There are multiple initiatives in the world and in Europe specifically about autonomous driving. Many companies are doing this. Some of these companies are actual companies operating massive taxi fleets, like Bolt from Estonia, for example. Other companies are just making the software to empower this autonomous driving functionality with other companies. And it seems like they operate the tremendous amount of data. And the kind of data that they operate is like it was said in the Forrest Gump movie, like peas and carrots for SMRs, because big files, purely sequential, and the telemetry that the cars generate, it's exabytes of data. And we're working with a few prospects in this field. It's not mentioned here as the separate use case because we don't have a real customer for this now, but it's coming, and I want to emphasize that these new developments, partially triggered by AI, they also contribute a great deal to generating more and more data. Next slide is about high-level architecture and high-level protocols that we support. As I mentioned, we are purely fully compliant POSIX file system. We have NFS, we have Samba, we have GIFs. Recently, we enabled Object. And all of this is available in the open source file system. And the commercial offering is specialized on the features and functionalities that are really needed for the big scale. So if you would ask me what is the main differentiator between commercial version and free version, and if the answer would be in one word, then the answer would be scale. So when it comes to actual scale, you need to embrace technologies that are not available in the open source version. You will need to upgrade. Upgrade can be done seamlessly. One command basically, and the installation will have these features for the big scale. Our go-to-market or GTM model and market mechanics. In the early stage, we had a few deals when we sold from us directly to the customer, just to try the waters and see how it works. Now we are moving away from this and we want to be a channel first company. We onboard partners, storage-centric partners in various geographies that can work with us to unlock local opportunities because they know local markets and they know it better. And the good thing about this approach is that we are very active in various storage-related conferences. We have, I don't know, at least one per month. And we met excellent people from different corners and in the world. Like, for example, we are entering into a partnership with a very big Australian and APAC integrator, the company called Xenon. Maybe some of you know them. Very knowledgeable people with a very good context that can extract benefits from cooperating with us. And there are other examples of that.
Do you have any partners in Germany or Western Europe?
In Central Europe so far, speaking of the Western Europe, we have been onboarded into one distributor, Tech Data Synex. And we are also being onboarded into them in the North America. Speaking about technology alliance partners, we are super close working with the hard drive makers first. Mostly I'm talking about two of them. It's Western Digital and Seagate, because Toshiba is a kind of outsider in this race. But with Seagate and Western Digital, we are super close. They ship us their hardware to qualify with our software stack in order to create reference architectures for big deployments that can later be copy-pasted into multiple projects popping up here and where, specifically in Europe. So, speaking about the costs, my chief revenue officer didn't want me to mention any numbers on the slide, but I still did.
We don't see the slide.
Sorry. It wasn't intentional. So when I mentioned that we can be competitive in comparison to tapes, I actually meant this. So because the software stack is already created, of course, we will be adding more functionalities as we go. We will be adding new features and all of that. But we are fine to be as low as sub-euro per terabyte per month. Of course, depending on the competitive landscape. So when we have the deal to beat tapes, we can go as low as needed to make it happen. In other cases, of course, we can charge more with more functionalities, and we can do this very easily. Speaking about sweet audiences or best spots in the industry, how we see it right now, I will start with Europe, because in Europe we have a very interesting situations these days with data sovereignty topic, some kind of breakup with the United States. And people are starting to think more and more about data sovereignty topic, about products that are invented and built in Europe that can contribute to this cause. We have a very good position when it comes to discussions of this kind. We obviously try to benefit from them. And I wanted to mention that some of you may know that a few weeks ago there was supposed to be a very big Euro HPC event in Cyprus.
Yeah.
That did not happen due to hostilities in the Middle East. Unfortunately, it was cancelled and it will be moved to a later date. But we had some discussions, very good discussions scheduled there. And now, as we see in Europe, there are multiple local initiatives that are commonly called as AI Gigafactory. We are participating in one of them in the Nordics and the Baltics. There are other in Central Europe. There is a Southern Europe hub and some others. that have the primary objective to build the local infrastructure from data centers to renewable energy, to actual racks, to actual servers, to actual software. That will be of Europe origin. Very interesting initiative, very interesting volumes of data, and we are trying to participate there.
I don't see on your slides the logo European product.
Say it again?
So I don't see on your slides the logo that you are a European product. But Estonia is European.
It was on the first technical slide. It's here.
But there's an icon for it, huh?
It says here.
That was there. So,
It's difficult to see.
point taken.
Yeah, we have to promote Europe.
From Russia.
Where
Estonia is
are
Europe.
those places in the world when there are no risks?
But then some places are more, and some places are less.
It's just the way of self-defense. I mean, many people, and I know a lot of people who moved to UAE recently.
Well, this is
No, it's a
probably
safe
the
area.
best move.
Probably not the best move,
No.
but it's like an afterthought, right? So now you understand that it wasn't the best decision to make. But when the decision was made, it was considered to be like a very good one. Tax incentives, good climate for some.
How much of the revenue do you do in percentage?
Where?
In Europe,
In Europe,
yes,
as of now, it's 80%.
80%.
Yeah. We have a few customers in APAC and coming customers in the United States that can overshadow this amount, but now Europe is the focus.
Yeah.
And moving from, again, it's more like, I think the answer would be more personal, not like business. Estonia is where we are from. I mean, the roots are there. We like it. The environment is very good despite these challenging times. This country is super creative when it comes to innovative technologies and all of that. It's open to the world. Of course, to flee to some better place can be the option. But in order to do this, I think the situation must change to the West significantly in the first place. Next one is about the spectrum of HDD-based workloads where we are a good fit. As I mentioned, we can be as affordable from the financial perspective as tapes, and we can serve the workloads from cold to cool to nearline and warm on even SMR drives. And speaking about performance, I decided not to overload the slides with technical data, but I will give you one sneak peek. We are oversaturating 100 GB network on a JBOD. So it's not about being slow when it comes to HDD-based storage, and we can outperform on the performance the likes of Ceph 2 to 3 times very easily, even on SMRs. And this is the full spectrum where we see our fit, and this is the full spectrum that we developed with the prospects we have in our roadmap. A few examples of real-life deployments that we have. I will start from the top left corner. National broadcaster with multi-petabytes installation of data. The actual use case with them, they actually have 2 use cases. First is the media archive, and the second use case, which we found ourselves very good at, is video on demand. So something like local versions of YouTube when the data is written to the storage and then read multiple times, like video streaming. SMR drives are an excellent fit for that. Next example would be Regional Hosting Leader. It's the company from APAC, actually from Japan, to be even more specific. They are one of the biggest web hosting companies in Japan, and they use our storage to provide enterprise file sync and share services. So they use us as the backend to provide the functionality of the kind of Dropbox level software for the users. Supercomputing centers, what we see, excellent fit, and we have run a few POCs with some of the biggest data users in the world. Will not name this at this point in time. More POCs are scheduled for the next months, including the biggest data user in the world I have seen so far. Maybe there are bigger ones, but I don't know. And they are happy to run POCs with our software stack and adopt them if the tests are successful.
And so, could you dig a bit in the technical details to understand exactly why you are so fast in running the hard drives? Is it because you need a special servers where you can parallelize, I don't know, bunch of every 4 drives?
Yeah, this question mostly belongs to the technical part, but I will address it now. So, first and foremost, we have come to this SMR topic not from out of blue. We had the information about the SMR drives before we even started this company. We helped one big company to adopt them in the past. So we had the knowledge about constraints and habits that we need to overcome to make it happen. But it's not only that. Currently we have the iteration number 5 of our SMR module. And these iterations are following this movement from cold to cool to warm to fast. Because in order to make them work fast, you need to fine-tune and optimize algorithms specifically about garbage collection, zone management, and all of this low-level stuff to make it really fast. And answering your question about hardware, our typical reference architecture is very simple. So it's like one U server, we call it a head server, like head, that connects to a JBot through external HBA card. And this server is very simple by the hardware perspective. We like it to be single socket AMD box, 16 cores, 256 gigs of memory, a couple drives for operating system, 100 dual port NIC.
And so you use parallel connection to the 1G board from one server to one
we are
board.
massively parallel file system. So of course, when we write and when we read, we do it from as many drives as possible to maximize the throughput.
Okay.
So it gives the performance.
Okay.
Could you compare the work you did on hard drives to the work you did on SSDs or on?
Whose work?
Well, in optimizing the software handling of the hardware storing data.
It's a good question. I would like to address it in the next technical slides, because I will give a sneak peek into what we are going to do with Flash, and this question belongs actually there. A good one.
But when it comes to autonomous driving,
Yeah.
what are the key risks of handling and storage for AI pipelines?
Key risks?
Yeah, key risks, like from a security angle.
Maybe you can rephrase it a little bit, because in my opinion,
Yeah.
how we see it, when it comes to this kind of deployments, it's the on-premise installations, because we are the storage for on-premise. We are not having the own cloud from which we provide our services.
Okay.
So it's on-premise installation. And then the security perimeter all of these measures beyond of our control and expertise. It's provided and maintained by the operator of this data. So if it's something local, isolated from the outside, then it's up to them how they do it.
Okay.
One sentence here more about reference architectures. We work very closely with Western Digital, with Seagate, and some OEMs vendors to create reference architectures, or in other words, blueprints with verified hardware specifications for different scales that can be taken, for example, for tenders, for big projects, and just copy-pasted into these installations to provide for maximum performance and maximum protection of data. So moving to the technical slides. How we are on time?
Half an hour.
Half an hour.
Okay. So this is the content that I'm going to present with the technical slides. And not to forget, I will start with your question about Flash. It's a good one, very good one. Let me get here. Here. Not the first slide, but it will answer your question. So when I say that we are HDD native these days, it means that our primary objective and our main vision is to work with HDDs as close to the actual physics of the actual iron as possible. We want to unlock the functionalities that have been present in the hardware for decades, like pin-free feature for energy reduction, like CDL for command duration limits to improve the responsiveness of the data storage, head depopulation to avoid situations when the drive that can perfectly work for 5 years more is thrown away, with SMRs that embrace the sequential approach to the drive. And I want to emphasize that the sequential approach to the drive will benefit not only SMRs. When it comes to CMR drives, they will also provide a higher throughput when they are accessed in the sequential way. So to Flash. With Flash, we have had a very interesting evolution of the thinking. So even if we take our current software stack, we can run on Flash. But we will be like a generic Flash storage without any distinct advantages. No high performance, no anything interesting. Because even if we are a small company, we are very, let's call it a storage innovation driven company. For 3 years, we've been talking to Storage Developer Conference by SNIE. This year will be the second year of talking at the Los Alamos MSST conference, in CERN conference. So we are exposed and we are driving to some extent the innovations happening in the world of storage. And our approach to Flash was, we don't want to have a generic Flash storage. We want to have it like with some twist, as we call it. What might be the twist? One idea that we started with was the technology called FDP. FDP stands for Flexible Data Placement. In a sense, it's the technology that allows you to control the data placement on the flash drive through the brains of the host operating system. This technology would benefit the hard drive performance. This technology would reduce the latency of the data storage access. But the problem with this technology, FDP, it's a very good one, and it's part of the NVMe standard. It's not like we are inventing again. It's in the NVMe standard already, but no one really supports it. The problem for us with this technology is that FDP is designed for sequential workload. And here we have this question. If flash is for sequential, what for are HDDs? Because our SMR-based storage is the perfect fit for sequential workload. And flash is put aside because flash is the remaining storage medium that must run the random workloads. Databases, virtual machines, you say it, what else? And we decided that FDP might not be a very good differentiator because it would mean that the workloads that can land on flash will need to be sequential, not random. And the main benefits of flash with tremendous amount of IOPS per drive will fade away. So we started talking to all the major flash vendors, Kioxia, Samsung, SanDisk, Phison, some others.
Micron.
Not yet, I need the contacts from you. They are on the list, but not no good contacts found yet.
Okay.
And we had, I think, close to 20 very deep technical discussions, combined with all of them. And we developed the concept, which is called, it's mentioned in the lower block of this slide, HMOP. HM stands for host managed, and OP stands for over-prof. So what is the potential over provisioning? What is the potential beauty of this technology when it will be implemented? It's a very interesting story. So when you look at your normal flash drive, for example, for simplicity's sake, let's take the drive of 16 TB capacity. 16 TB is usable capacity. And also on the drive, there is some amount of spare capacity that replaces the bad blocks when they are found on the usable capacity. How it works currently? The controller, which is present on every drive, when this over-provisioning limit is about to be exhausted, like 10% left as an example, 10% more. So the drive is 16, but we have 18 in total on the drive. This controller marks the drive as boomed, failed, swap it. So what we are trying to implement, talking to these flash vendors, is to shift the border between usable capacity and spare capacity by managing it through our software. Similar situations like it was with what we mentioned about MATE implementation in the past, when this logic was kept inside the controller, RAID controller card. They are rather stupid. So when they realize that the spare capacity has hit the limit predefined in them, they immediately mark the drive as faulty, while the drive can potentially serve for years. And we heard it from the vendors that it's not possible to imagine that 100 TB flash drive will be thrown away in the dustbin if just, 500 gigabytes of it got faulty, like less than 1%. And this is what we are trying to implement with this flash initiative. We want this to become the part of the standard. We are working with OCP group, we are working with flash vendors in order to move this initiative. So what it would mean for the end user if/when it's implemented. The main hard value for any big data user, unfortunately or fortunately, is not performance. It's the hard financial value, or in other words, total cost of ownership. How much it costs to run deployment X over 5 years, which is typical amortization time period for infrastructure. And if we are able to extend this 5 years to 7 years, both for HDDs and flash, it would mean that the total cost of ownership will drop 40% on average.
But it will also mean that hardware vendors will sell less hardware.
It's a good comment, but they are not concerned about that. Because their current belief is that the demand will still be happening. And when this organic growth happens, this functionality, if it's implemented, would not mean that their revenue will suffer. But what they will benefit from this is that their drives will be used to the fullest, to the last day of their potential life. And they will be used by many people because more people want to reduce their capex on hardware. I like to use this example. I don't know, when you go to the coffee shop and you order double espresso shot, and when the bartender gives you that bag, do you like to see just the sediment on the bottom of the cup, or you want to see the full cup? I think the answer is obvious. So if you pay for the hardware, doesn't matter, HDDs, flash, whatever comes next. You want your investments to be well defended for the future, and we are just helping the end customers with data storage to realize that. So this is our take on flash. Not confirmed yet, so it's like completely and purely a sneak peek into the future.
So would you, if it's a standard, it wouldn't be owned by you anymore, it would go into any hard disk which the vendor wants to buy?
Yes, in the technical terms, what flash vendors needs to support is just one command. In Linux, it's called shrink. So they will be able to shrink this extra capacity present on every drive, just to tell the controller, please stop it. Do not mark drive as faulty when some threshold has been exceeded. Don't do it. And the remaining part of this logic will be governed by the host, by us. So it will be for all, you're right. But in order to reap the benefits, people will need to develop these functionalities into their file systems. And we will be the first with that, hopefully.
So you would be able to manage SSD banks as well as hard disks?
Basically, yes. Hard drives are fundamentally different from the technology component from flash drives, but the high-level idea is the same. So we want the brains that are in our software stack to be capable to manage the physics of both HDDs and flash drives, because it will extend their lifespan, it will increase their capacity, and it will give the CFOs much better total cost of ownership at the end of the day.
We lose the screen.
For me, it's
Could
theory.
you work with your SSDs today because they
You have
have
to reboot TV.
special software on it which has a lot of this optimization?
You have the remote control
For TV.
no, for the TV.
Because
It's shut down basically. You touch something?
There was a message for the saving.
Swiss sabotage?
Why not?
Look, okay.
it's something else.
Okay, so
It's not me.
Europa will run.
should reappear now. Okay, so we lost the years. Where is your famous menu to mirror the screen?
Il n'a pas marché sur un fil, non?
No. Mirror the screen.
Settings.
Yeah. Display, there is monitor or display, something like that. Display.
Oh, c'est grand que ça.
Maybe more. We need to make
Is there a display or monitors in here?
Parce que le système de contrôle est sur, repose sur les disques durs.
Ah ouais?
Ouais.
Two, yeah.
Two or one? No,
Two,
no,
two. Yesterday
Two,
they
yes.
they put another cable.
Yeah, but yesterday was the first day. Today's the second day, so we'll probably move to HDMI 2 for the second day. No?
Ah, ça marche.
Now 3.
Je comprends pas. Ça marche, ça marche.
Yeah, je viens de le faire. Mais...
Ah, c'est bizarre.
Alors, so, okay,
There is time.
Display. Should be here. Normally it should be on the top.
Which
no?
one?
Don't have the right icon. You're on the screen. Yeah, okay.
Fits. Something happened.
Please don't start when you go.
Let's try to turn it off the line.
The problem is again the cable.
You want to the cable?
Just shoot maybe.
It's Italian troubleshooting? No.
But, if it does not work, it's the cable. But it works, so is your adapter.
So it's not mine. It's
Okay.
Estonian adapter. So let's
J'en ai un, j'ai le mien aussi. Hein.
let's
Let's
try.
try. Yeah.
Ouais, mais c'est marrant pourquoi ça marchait jusqu'à
Let's
maintenant.
try Egyptian. Let's try this Egyptian one.
The cable works.
Working or not? No, it's the same. This is a cable. No, you said the cable works.
The cable works.
Yes. Oh, okay.
But don't move. Don't move.
I stay like this. So full screen, yeah, view. Full screen. Very good. We are back.
Sorry for that. We stopped at the question whether we can work with Flash these days, right? And the answer is yes, we can, but we do not have any distinct advantages over the generic Flash storage systems. So just the ordinary performance, ordinary features, and all of that. With this initiative, if it takes off, we see a very good potential with that, and it's not only my opinion. As I mentioned, it's based on the ongoing discussions with a few very significant Flash vendors that share the good signals about the potential of this initiative. Minutes. So a few technical slides to give a better taste where we are coming from with our architecture. We discussed this topic in depth during the Rome session, and we are the grandson of the Google file system architecture that was published approximately 20 years ago, and we are based on the principles shared by Google which were later adopted by many other distributed file systems in the world. Some of them have become more successful than the others, but we are standing on the shoulders of this architecture. The main problem with this architecture is the metadata management, which is very critical these days. And to be more specific, this architecture has one very important bottleneck, which is called master server. The server that manages the metadata. What is the problem and why it is so big? Because it's just one master server. And it means that the current limits of this architecture that were not so visible 20 years ago when Google published this reference architecture, 10 years ago. The main constraint is that metadata is kept in memory.
It's not even redundant, is it? The master server is not even redundant.
It's redundant in a way because it has the so-called shadow server that maintains the copy of the data from master, and it can be fallen back to the shadow server. But it's not a true redundancy in a way. And this problem with metadata kept in memory has been becoming more and more visible these days because data volumes are growing, metadata volumes are growing. How you can keep all of that in the single master server? Because it would mean that if you want to manage billions of files, you have to deploy 2 terabytes of RAM per server, which is an insane idea in a sense. So this constraint and this limitation of the Google file system architecture has been present from day one, and we started solving it approximately a year ago, and we are solving this by extending this architecture to have the distributed metadata server, so that we will not be constrained in growing the capacities to past a few billions of files that we can do today, to dozen billions, etc., by introducing the multi-master architecture with master servers scalable as needed. If you want to deploy 100 petabyte installation,
No.
shit.
Ah, c'est le fil. You have to be careful, don't
Yeah,
walk
on the cable.
on
Yeah.
the cable.
Don't
walk.
put your
It's not about cable. It's about screen being timed out after the
Ah,
start.
okay.
Maybe you
Oh, okay.
should deactivate the power save mode.
So yes. So,
I will try to touch it very frequently.
No, you just deactivate power saving. And then it leaves it on all the time,
Yeah.
and you won't have that.
just add 10 minutes to the battery screen hibernation. No?
Yeah, but I'm not sure where I find it.
Find it by power save or something. Energy management or so. Power save. Deactivate.
Informatique, c'est compliqué.
Or we can download the slide and just follow.
Yeah.
Because then you put online.
Yeah, the presentation.
Yeah.
You have the presentation?
That's it.
Oui, je l'ai envoyé.
Everything is automatic. And control it. They don't control anything.
Ah ouais.
So we are solving this problem with a single master server by implementing the distributed metadata at scale. It will be available middle of this year because we are close to completion of this tectonic task. And when it's implemented, we are not going to be constrained anymore by the number of files that we can have in our installations, by the potential to scale to exabyte level.
And so actually, this distributed metadata at scale. What is exactly? So you put metadata server inside as a VM inside every node? Or?
It's the service that runs on the installation.
Okay.
When it comes to hardware/architecture description, it runs on the same one new server,
Okay.
which is connected to every JBoss.
But then you have 3 or 4 or 5 of those to host the
Eight,
data.
8 or more.
8 or more.
Yes, I mean, in theory, it can be possible to run our software stack on just one server, forgetting about redundancy, data safety, and all of that. When it comes to normal installations, as we call them, we prefer to use Erasure coding scheme 6+2, meaning that we must have at least 8 nodes. But with Erasure coding schemes, we can be very flexible. It can be any. We have one customer running it like 12+2. Fine.
But 8 is the minimum. Should
It can be 3+2, but the higher Erasure coding scheme, the less penalty on storage you have.
so you have parallel access to all these
Yes.
metadata
Yes.
servers, and they also can replace each other if one of them dies off.
Yes.
And then you can put another one in, it will coordinate with the others. And
Yes.
so you will always have, as long as the connections are okay, access to metadata in very short time.
Yes, when these distributed metadata servers are implemented, it will be always on architecture.
And I mean, from which size on would you advise to implement that?
When it comes to SMR-based installations, we would like it to be no less than 4 petabytes.
Because you mentioned in the scenario, in the use case scenarios, CTV video surveillance. So I guess for CCTV video surveillance, you are not going to put a lot of data. I mean, if I'm on a building and I have, I don't know, even 6 or 7 cameras, I'm not going to put so huge
Sure.
capacity of storage.
In the end of the day, it depends on the capacity under management. So if you are fine with some NAS box, I don't know, QNAP or some others that can store your data fine, you just don't need to have a distributed file system. Period. So we are not trying to be everything for everyone, and with our data storage product, there comes the minimal threshold. Of course, as I said, it's possible to start with a few servers, 2 units, 12 drives each, and then you will grow. But if the intention is to grow at a very significant scale, you should think in terms of JBots most probably, or storage servers like 60 drives or more. And in this situation, when you want to have a proper data redundancy, for example, you start with 6+2. And you can deploy, for example, 24 drives in each JBot. If you multiply 24 drives by 30 TB capacity, and then you will multiply this by 6, which is the data part of the Erasure coding scheme, because 6+2 means 6 data, two parts for parity.
Yeah.
You will get the usable capacity. So 24 by 30 by 6 will be the minimal in terabytes that we believe is acceptable.
Okay.
This is our sweet spot. The more the better. Because with our parallelism, we benefit from the number of drives.
As far as I understand it now, it's all local. What about different locations for different data servers? I mean, like I could have one amount of data in this location and one in another. Does it depend on the connectivity then?
Yes.
Or?
A good question. Thank you. Currently, we support the synchronous replicas in the metro distance. So if a customer has, for example, two sites connected by the dark fiber, which are not farther than 10 kilometers from each other, then it can be done in the real time. We have one of customers like this, having the deployment between two buildings of them in the same city. It works fine. When it comes to bigger distances, it can be done in the async manner with some delay. So multi-site is possible as part of the architecture.
And not, I don't mean multi-site as for redundancy purposes, but because you have your data somewhere else, because you have different daughter companies or whatever.
Yeah, it's totally possible. Well, you mentioned the dangerous life in Estonia some time ago. One example from 2 or 3 weeks ago, we participated in the local event, and some people from the defense forces came to our booth and said, guys, we need 2 copies in 2 data centers. If one is being hit by the rocket, we need the data to survive in the other one. These are the realities of these days. Yeah. And they were talking about metro distance. So with metro distance, especially when the sites are connected by the dark fiber, it can be real time. Yeah. Erasure coding that we partially touched, we are super flexible with erasure coding. It can be any scheme, and this scheme can be controlled on the file level. So if, for example, you run the cluster with a 6+2 erasure coding scheme, you can manage, or you can set the higher erasure coding scheme or lower erasure coding scheme for the data that has more or less importance to you. If you have, for example, data that you cannot lose at any cost, like never, you can increase the erasure coding scheme to ensure that the data is protected better and more. At the same time, for erasure coding, one important comment here that many software-defined storage systems, Ceph included, and I think most of them, are doing the erasure codes calculation on the storage servers. And when the erasure coding is calculated on the storage servers, typically it provides rather significant overhead for CPUs in the storage nodes. And this is the reason, one of the reasons, when we compare the typical reference architecture for Ceph with our reference architecture, you will see like for Ceph, the recommended processors are like top-level Intel CPUs that cost a lot, because the erasure codes are running on the storage server that consumes more compute power. We do run the erasure coding calculations on the client, not on the servers. The client which is connected to the storage, and it's done there. The similar approach was taken, I think some of you know, by the company, well-known company called Hyperspace.
We know them.
When they acquired the what was the name? It was
Roseau FS.
Exactly. The industry gossips tell us that the main reason of this acquisition was to get the client in order to enable erasure codes calculation on the client side. Because it's not like what typical storage systems do. It's a good advantage because it allows to have less resource-hungry storage nodes. Multi-protocols, as I said, again, fully POSIX compliant, NFS version 3 and 4, Samba keeps S3 through Versity Gateway, and in the future, as I made it clear in my sneak peek, we're going to have a flash storage with some as well. I think it will be the last one. We wanted to make the start of usage of our file system, especially when it comes to open source or open core version, as easy as possible for every user. And we are making a very significant effort to make it happen by introducing our packages into the most popular Linux versions. I mentioned Ubuntu, Debian, Rocky, Fedora. We want to expand it even more. We want to become Kubernetes native. We have the operator, which is going to be open sourced as well. We have Docker image. And most recently, it's not reflected on the slide because it's a very recent activity with us. We have completed the development of the Proxmox plugin, our storage. All to make the storage enthusiasts to start with our storage product as easy as possible, to make use of the various deployment options that are easy to use. So, based on today's drive capacities, we are able to pack 25 petabytes of usable capacity per rack, which is not bad. When 40 TB drives are available, as some vendors announced a couple of weeks ago, it will be up to 35 plus approximately petabytes per rack. I believe this is it, given that the time has run out. Apologies for the few technical hiccups.
How many people are you? That's the question.
How many people we are? Yes, we are 14 people. Oops.
14 or 14?
14 or 14?
1-4.
Okay.
Out of these 14 people, 9 to 10 people are actively involved in writing the code. We have a very skillful and experienced team in C++ and data storage specifically. It will be interesting for some of you, especially those coming from Spain. Spanish is the most commonly spoken language in our company. That's fine. It's fine.
Are you profitable? Probably.
We are about to make break even.